Hello everyone. Today we're going to talk about analysis of selection problems. So let's say that in a problem in an array we are trying to find the largest number or the smallest number. Here is the very simple algorithm for finding the largest number. An array of S with the size n. And again we start the index as index 1 as the first item in the array. So simply you just put the first item as the largest one, then for all other items you are comparing the largest one so far that you found with every item at location I. And if you found a new one, the new largest item, then you're replacing the new item with the largest one, and you're continuing the search until you are done with until you go to the end of the array and you are returning the largest item or the smallest number in the case of the finding the smallest number. So now we're going to see what we are going to like to together. We're going to see a theorem about like the selection problem. So the theorem says that any deterministic algorithm that can find the largest of n keys in every possible input only by comparison of keys must in every case do at least n minus 1 comparison of keys. And remember, here we are not considering the arrays that are already sorted. So if you have an array that is sorted, and so the largest number is usually at the end of the array, and the smallest number is at the very first item of the array. So we don't need to do any search. We only return the last item for the largest item and the first item for the smallest one. So now let's see that how we can prove this theorem. Let's look at the problem again. So the problem is finding the largest number in the array. So we can say that the largest number, when we are comparing it with all other numbers, wins the comparison, and all other numbers lose the comparison. If we say that in every case we are not doing at least n minus 1 comparison of keys, so it means that at most we are going to do n minus 2 comparison. So this means that we might have two keys that are never never lose. They never lose the comparison. So let's say that these keys, two keys are Si and Sj. Okay, one of them can be the largest one, and the other one is the one that we haven't compared because we said that we have n minus 2 comparison at most. So let's have, and we have this array that you see here from S1, S subscript 1 to S subscript n. Now let's have another input, okay, with all other like the similar identical numbers, except that one of these numbers we are gonna like replace it with a very large number that's gonna be more than that's gonna be larger than or greater than these numbers that we have in this array. So what happens is that, again, when we are doing the search, let's say that this new item is called S of k. This new, one of these items, we replace it with sk. And sk is the largest number, that very large number. That is, we know that for sure is greater than all items in this array. So what happens is that when we are doing the search, okay, because we are not comparing these two items, this sk will not be reported as the largest number. Indeed, the other number will be reported as the largest number. That is wrong, because the search algorithm should find the largest number, that in this case is sk. But as we showed, like if we have n minus 2 comparison, we might not see this sk be reported. So it contradicts our assumption, okay, that it at most does n minus 2 comparison, so at least it should do n minus 1 comparison. Now let's take a look at another problem. Let's assume that we're going to find the largest and the smallest numbers in an array. Now we have here two examples, an array S and array T, for finding what's going to be the best case and also the worst case. So this is our function that finding both values, and we don't care about like returning two values. Okay, we just it's a pseudocode. And again, we start index at 1. So we are putting the smallest and its largest number both equal to array S or the array that we are given at location 1. Then for I equal to 2 to number n, that is the total number of array that we have, then we are doing the comparison. If the array at location I is less than the smallest number that we found so far, then we are updating the smallest. Otherwise, we're checking with the see that if the item location I is greater than the largest number, and if it is, then we are replacing and updating the largest number. And at the end of the for loop, when we are done, we are returning the smallest and the largest number. So let's see that how this algorithm works for these two arrays that we have. So we have array S and we have array T. As you see here, array S, the first item is 6, so both the largest and smallest numbers are equal to 6. So let's write it here when we have array S. So the largest, I'm going to just write it L, is equal to 6, and let's write it as SM equal to also 6. So what happens is when I is equal to 2, we are comparing with the smallest number. That here the S allocation I is 5, and we are comparing with the smallest number, that is 6. And because the 5 is less than 6, so we are updating smallest number, and now it becomes 5. But as you see, because this if condition holds, okay, so we are not going and check this if condition that we have here. So as you see, if you just continue this process, you were gonna see that we never gonna call this go and call this else if statement that compares the item allocation I with the largest one. So the best case will be equal to n-1 comparison, and that n-1 comes from the number of comparison that we are doing for the first if condition. However, on the second item, okay, so the best case, okay, for this search was n-1. Now we're gonna see the worst case. So look at the array T that have the item 0 as the largest and the smallest for now. So for array T, when you start the algorithm, the largest item is equal to 0 for now, and the smaller one, just I'm gonna call it SM, is equal to 0. So we are going to the for loop, and I is equal to 2, so we are comparing the value location 2 that's equal to 1 with the smallest one. And because it's not the smallest than the it's not smaller than the smallest value, so it goes to this second if condition or if statement that we have here. And because 0 is less than 1, so we are updating this largest one here, so it becomes 1. Again, when we are comparing number 2, that is the third item, so it means that I equal to 3. Then because S allocation I that is equal to 2 is not less than 0, we have to go and again do this comparison again. So in this case, that we are updating this one again, so it's going to be 2 until the end of the array. So in this case, what happens is the number of comparison becomes twice n-1, because we are doing n-1 comparison for the first if statement, so n-1 here, and again another n-1 comparison totally here. So together the worst case will be twice n-1, and the best case was n-1. Now let's see if we can do better for finding the smallest and the largest number in an array. So at first, let's assume that the number of items in the array is an even number. So it's divisible by 2. So this is the algorithm for finding the both largest and the smallest number with a better approach. So for doing this, instead of comparing individual items, we are dividing the array into pairs. Okay, so it means that, for example, if you have S at location I, then also we have the S at location I plus 1. we are creating these pairs, and we are comparing these pairs. Then we are comparing the result of these pairs with the rest of the results so far. So this is how it works. First of all, we are checking the array that we have, let's say array T. So array location 1 with the array location 2. Then if this item allocation 1 is less than allocation 2, so it means that the smallest number so far is T allocation 1, and the largest so far is T allocation 2. So, and otherwise, okay, so it's vice versa. Now, after doing this, we complete the first pair. Okay, we initialize our largest number and the smallest number, and now we can continue our the selection part, that is finding the largest and smallest. So because we already compared the first and second items, now we start at location 3. And again, as we said, that index start at 1 in these examples. So for I equal to 3 to n minus 1, and we are each time I increases by 2. Again, because we said that we are gonna compare pairs. So that's why we are increasing after each loop, we are increasing I by 2. And the reason that we are going to n minus 1 also is obvious, because we have a pair. So n minus 1 it creates a pair with item allocation n. So that's why we are going to n minus 1 and not n. So here, first of all, we are checking that if T allocation I, again, similar to what we had here, is less than T allocation I plus 1. So if this is the case, so it means that we have to compare the T allocation I with the smallest number, and T allocation I plus 1 with the largest number. Okay, because we already found that Ti is less than Ti plus 1. So there is no need to compare the Ti allocation I with the largest one and T allocation I plus 1 with the smallest one. So somehow we are saving the number of comparison. Otherwise, if T allocation I is not less than T allocation I plus 1, so it's greater than this one, again, opposite of what we had here. So it means that the T allocation I plus 1 should be compared with the smallest one, because we already found that it's less than the T allocation I. And as I look, sorry, I think I need to change this one. This should be T not S. So here, let me change them to T here, and also T here, and T. So if T allocation I plus 1 is less than S, then we are updating the smallest number. If T allocation I is bigger than or greater than the largest number that we found so far, then we update the largest number here. So let's see what's gonna be the every case time complexity when the number of items are even. So we have an even number of items in an array. So first of all, we had one comparison here for seeing that what's gonna be the condition between the first and the second item. So we have one comparison here. So T of n is equal to one comparison so far plus. Here we have the for loop that goes from 3 to n minus 1, but the steps goes from, the step is of size 2. So each time we are increasing I by 2. So we are doing half of this for loop doesn't go from n minus 2 wise. It goes n minus 2 divided by 2 times. And also, so this is the number of times that we are running the for loop. But inside the for loop, we have one comparison here for every time that we are doing the loop. And also we have two comparison inside also the if loop step, either if statement that we have. So for every loop that we are going, we have first one if loop, if condition, if statement here. And also, no matter which one is gonna be true, then we are doing another 2 comparisons. So together it's gonna be 3 comparisons. So we're multiplying this number 3 by this n minus 2 divided by 2. And if we just like to simplify this equation is going to be 3n divided by 2 minus 2 for when n is even. And when n is an odd number, okay, it's really easy to modify this one. Okay, so one way to like to do that, okay, is that you are, let's say that having this example here, and let's say that, for example, n is equal to 7. So what you can do is keep the first item, okay, separate from the rest of the array, and you are doing what we did here, okay, when n is odd for the rest of the array. That is when we have a sub-array of n, let's say n prime is equal to 6. So for when we have like this, like doing the comparison and find the largest and the smallest number for this part of the array, as we said, because then now n prime is equal to n minus 1, and now this is an even number, okay, even number. So we said that for this n prime, okay, it's gonna be t of n prime, gonna be, and now let's try to find the t of n. It is equal to 1 plus 3, and here, as you see, we passed the n minus 1 items to the array, not n, because n was an odd number. So instead of n, I'm putting n minus 1, so it's gonna be n minus 1 minus 2 divided by 2. Now I found the largest and the smallest number with the rest of the array, and now what I need to do, I need to do two more comparisons. One comparison is to see if it's less than the largest number or not, and the other one is to see if the first item that I have here is small. So let's if the first comparison to see that if the first item is less than the smallest number, and the second comparison is to see that if the first item is greater than the largest number. So I'm adding two more comparison to this function that I have. So again, the first part is when I'm like breaking the array in two parts. The first part only has the first item, and the second part has n minus 1 item. And because n was an odd number, so that's why I did this one. So for the even part of the array, so I have this number of comparison that I calculated above, and instead of n, I'm putting n minus 1 because that's the new size of the array. And now I need to do two more comparison. So if I have these numbers simplified the equation, it's gonna give me 3n divided by 2 and minus 3 divided by 2. So that's the every case time complexity when n is an odd number.